Hi everyone, welcome to this course on Oracle Cloud Infrastructure Fundamentals. This is the first lecture in the Fundamentals series focused on core cloud concepts. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. So in this particular lecture, let's look at what it means to use cloud. Cloud is very different than on-premises infrastructure and environment. So we'll look into that. What does it mean to have different service models in cloud? We'll look into that. What are some of the common cloud terminology like elasticity, fault tolerance? We'll go over those. And then what does it mean from a business sense to use cloud? So we'll talk about capital expenditure and operational expenditure. So let's get started. Well, the best place to find the definition of cloud computing is through the National Institute of Standards and Technology. And even though I have given a link at the bottom, so you can find in 2011, they came up with the standard definition of cloud computing. And even though it is a bit dated, going back to 2011, the definition they came up with is still very relevant. And just to close on that, they have updated those standards in years since 2011. So, and you can always find the latest out on the web. But let's go over their definition, and it's actually closely resembles most of the public cloud environment. So the first thing a cloud needs to have is this concept of on-demand self-service. You should be able to provision computing capabilities as needed without requiring human interaction with service provider. So you don't have to go to a service desk or a help desk and request a virtual machine, which takes a couple of days for IT to provision for you. It should be all based on demand and self-service. The cloud services should be available through broad network access and using standard mechanisms, the web standards. So this again says that you should be able to access these using self-service mechanism, and you should be as simple as using let's say a web console. In a cloud provider environment, the resources need to be pooled. What does that mean is the resources are pooled to serve multiple customers using this model called multi-tenant. And we'll look into that as we get into subsequent lectures, with different resources dynamically assigned and reassigned according to demand. Why do you do this resource pooling? Well, you pool these resources, you make them available to customers so you can save money as a provider, and then if customer needs more resources, you can give them, and some customers need less resources, you can take away the resources. So this dynamic pooling, is a core essence of cloud. The fourth one is rapid elasticity, which actually ties well with closely with the pooling concept. Capabilities can be elastically provisioned and released in cases that automatically to scale rapidly outward and inward depending on your demand. So if your demand increases, you can get more resources. You have elasticity. If the demand is not that much, you can release those resources. So this goes again very tied closely with resource pooling concept. And then finally, the services can be monitored, controlled and reported, providing transparency for both the provider and consumer. So this concept of pay as you go or consumption based pricing, where whatever you consume, you only pay for those resources, and you have complete visibility into what you're using and what you're paying for. So these five things, the five broad areas which NIST covers, is actually pretty true for a public cloud environment. All right, so let's look at some of the service models which are prevalent. The one which you are familiar with is the traditional IT. In this case, your IT organization manages everything end to end. So whether it's your core infrastructure or whether it's some of the higher level things like your middleware and runtime, everything is managed by your IT organization. So the first model, which we talk a lot more detail subsequently, is infrastructure as a service, sometimes also referred to as IaaS. So in this particular model, the cloud provider manages the core infrastructure. So what that means is the cloud provider has data centers, the physical infrastructure, the servers, the networks, the storage machines, even the virtualization layer is all managed by the cloud provider and delivered as a service. And you as a customer are responsible for things like your operating system, your middleware, your apps, and your data. Those are all your responsibility. So good example, you get a virtual machine in the cloud, you have complete control over it. You could install whatever operating system you want, whatever application you want. So that's a good example of an infrastructure as a service offering. The second model in the cloud is platform as a service. So in this case, the provider is responsible for managing a little bit more than infrastructure as a service. So the provider is also managing things like your runtime. So let's say you have a Java runtime or you have a Node.js runtime. And what you do as a customer is you can write your applications and you could run them on the platform without worrying about the underlying virtual machine. You don't get a VM, you just get a runtime environment. Classic example here are serverless offerings. So we at Oracle have an offering called Oracle Functions, and that gives you various runtimes, and you could run your code on those runtime, and we take care of things like scalability, high availability, etc. Now the one of the big difference between this and the infrastructure model is it takes your pay as you go pricing to even the next level. You have this consumption based pricing, so your functions run only for a certain period and you only pay for the invocation. It's not like your virtual machine is running based on an hourly billing model where even if you don't use it you're still paying for it. So Oracle Functions, serverless in general, is a good example of platform as a service. And then finally, we have software as a service, where the vendor delivers everything as a service, all the components, all the layers as a service. So good example here would be ERP, would be a supply chain managed, in the cloud, or a human capital management SaaS offering in the cloud. Oracle has a bunch of these SaaS offerings as other providers do. So this is again an area where there are lots of offerings where you as a user are just interacting with that particular SaaS offering. You're not touching the VMs, you're not writing your own code or for your applications. All right, so let's look at another key construct. Now we are getting into some of the cloud terminology, which is around high availability. Now this is a core concept you really need to understand. Computing environments configured to provide nearly full-time availability are known as high availability systems, right? So that's basically what it means. What it means is these systems have redundant hardware and software that makes the system available despite any kind of failure. Well-designed high availability systems avoid having single points of failure, and we'll talk more about this in our next module. But the idea is because you have redundancy built in the system, you don't have a single place of dependency where things can fail. So a classic example is using a load balancer. So let's say you have two web servers here and you put a load balancer in front of them. And so if the web traffic is coming here, let's say you are running some kind of web site here. So if the web traffic is coming here, the fact you have a load balancer right in front of the web servers gives you some kind of redundancy. Now, when a failure occurs in these high availability systems, the failover process moves processing performed by the fail component to the backup component. The more transparent the failover is to the users, the higher the availability of the system. So in this case, what happens is, let's say this particular web server goes down, this web server is still running, and your website, whatever website you're running here, is still up and running. If let's say you had only one server running here, if this server had gone down, website would go down, right? So this is a very common basic example of taking a system and making it highly available. The next concept, which you need to understand in cloud, is disaster recovery. It involves a set of policies, tools, and procedures to enable the recovery or continuation of your technology infrastructure and systems. Now, the two key definitions which come up all the time are recovery point objective and recovery time objective. So what do these things mean? At a very high level, recovery time objective basically means how much downtime your business can tolerate. Recovery point objective basically means how much data loss or transaction loss can your business tolerate, right? So let me give you an example, right? Let's say your RTO is 24 hours, and so is your RPO, same as RTO 24 hours, but now they mean very different things, uh, just based on what they actually imply, right? So let's look at that. Let's say your RTO is 24 hours. This means that if a disaster happens, you are okay for having a downtime of 24 hours. So let's say your IT organization and your processes in place are there so that you can recover within, let's say, 8 hours. So if your recovery happens within 8 hours, you are okay because you can tolerate a 24-hour downtime. Now, instead of 8 hours, if the recovery takes 48 hours, that is not okay because your RTO is less than that. You cannot tolerate a 48-hour downtime. Let's look at case of RPO. Most of the businesses would do some kind of backup. So let's say you do a backup at 12 a.m. in the midnight, uh, and then the disaster happens at 8 a.m. So what happens in this case is your last good backup was done 8 hours back, right? So this is the amount of data which you have lost because your last backup happened at midnight. So in this case, let's say your RPO is 24 hours, you are still okay because you have only lost 8 hours worth of your backup data. Now imagine if your RPO is 24 hours, and if let's say your RPO was instead of 24 hours, let's say it was 4 hours. Now in that case, this 8-hour loss is not good because in that case, you have lost more data than your business can tolerate. So again, understand these concepts, core concepts around HA and DR are relevant when you talk about cloud. Let's look at some of the other cloud terminology. So the first one here is fault tolerance. Fault tolerance describes how a cloud vendor ensures minimal downtime for their own services. So for example, we looked at this previous example before, and we said avoid single points of failure. So the fact that you have two web server here uh, ensures that you don't have a single point of failure. But what about this load balancer? It is a single point of failure because if the load balancer dies, basically your website dies, right? So what we do in Oracle and other cloud providers is we manage a standby copy of the load balancer. So if there is an issue with this load balancer, we can switch the traffic to this standby load balancer. And in subsequent lectures, we will look into how we do fault tolerance for every service, whether it's storage services, it's database services, compute services, etc., etc. Now, the another concept which is relevant in cloud is scalability. Now, there are two kinds of scalability which are there. One is called horizontal scaling. It is also called scaling out. So what it means is you have a server here. Let's say you want to add more servers. So this is your scaling out. And along with that, if suppose you don't need these few servers, you could remove them, and you have this concept of scaling in. The other kind of scaling is called vertical scaling. And basically it means is if you have a machine running here, you could always get a bigger machine and a bigger machine and so on and so forth. And if you don't need a bigger machine, you can always go to a smaller size, smaller shape. So scaling up or scaling down. The next concept is elasticity, and similar to scalability, its ability to quickly increase or decrease resources, not just limited to virtual machines. It can be your storage, it can be your database, it can be any other load balancer, etc. Right? So the idea is if you throw a lot more traffic to my load balancer, my load balancer should be able to scale seamlessly, and so on and so forth. Now, the final topic in this lecture is around cloud economics. Now, I'm not getting deep into like every aspect of how the cost changes between on-premises and cloud, but the thing to note here is CAPEX and OPEX, the most common cloud terminologies. So, capital expenditure or CAPEX is the money an organization or corporate entity spends to buy, maintain, or improve its fixed assets such as buildings, vehicles, equipment, or land. So, good example of capex would be your data center lease, data center itself, right? You need to spend money to build a data center. You fill that data center with equipment. So there's capital expense involved with that. Example of operational expenditure or OPEX is the ongoing cost. So, for example, you might be in your data center, you are getting a power bill, the utility bill. That's an example of OPEX. The labor cost is an example of an OPEX. And what makes cloud so interesting is it lets you trade CAPEX for OPEX. So instead of having to invest heavily in data centers and infrastructure in the cloud, you can pay only when you consume resources. So you don't have to do a massive capital intensive build out, and you only pay for how much you consume, the pay as you go consumption based pricing. So it's a game changer. That's why one of the reasons on the business side, cloud is so attractive. All right, so we covered a lot of ground in this lecture. Let's just recap some of the core concepts we learned. Cloud computing, we talked about the different characteristics: self-service, available through network, ability to pool resources, provide rapid elasticity, and ability to measure what you are using. Service models, we looked into infrastructure as a service, platform as a service, software as a service, and we looked at specific examples. We looked at some of the core cloud terminologies: high availability, disaster recovery, fault tolerance, scalability, and elasticity. And there, of course, there are more terms, but these are some of the common ones you really need to understand. And then finally, we really quickly touched on cloud economics, what capex is versus opex, and why cloud makes it so why the cloud model is so much attractive from a business perspective, because it lets you trade capex for opex. Thank you for joining this lecture. In the next lecture, we'll talk about some of the core high availability design architectures in OCA. Thank you.